JavaScript is one of the three programming languages responsible for the creation of websites. And from a bug bounty perspective, it's arguably one of the more important ones, and it's going to help us find a lot of client-side vulnerabilities. In this video, I'm going to help you read and understand JavaScript so you can go after client-side vulnerabilities and get those nice payouts. Alright, no PowerPoint today, we're just going to go straight into a bit of Visual Studio the way it's supposed to be. If you haven't watched my video on understanding HTML, then please watch it. You'll be completely confused if you don't know how to read HTML, because JavaScript is kind of the next step up. And anyway, what the hell is client-side JavaScript? So client-side JavaScript, when people refer to it, means that it's being executed inside the browser. So here, it's being executed on the user's computer, and it's not being executed on the server, right? So nowadays, there's JavaScript frameworks which work on the browser as well, like JavaScript works in the browser, but then you can also run it on the server, like things like Node.js and stuff like that, for example. These are different because they don't have a lot of the same restrictions as client-side JavaScript does, and they're not really parsed the same way. They have different functions as well, and they're actually very different from each other. So what you need to understand is client-side JavaScript runs on the user's browser. Server-side JavaScript, when we're talking about stuff like Node.js, will run on the actual cloud, will run on the server, and it's not constrained the same way that client-side JavaScript is, because it's not running in a browser and it's running on a different environment. Right. Now that you know that, let's have a look at this HTML form. Whenever we're writing HTML, we're always going to be using client-side JavaScript and not server-side JavaScript. So, where is the JavaScript? Don't see it here. Well, it's actually not really practiced anymore that people will write JavaScript inside the HTML itself. They'll actually usually import it from a different script. So this is the way you see. I have it imported as script.js. We go here, this is the JavaScript, right? So it's basically automatically importing it for us. It's the same as writing like a script tag in here. You know, it's the same as writing a script tag and then writing all that, but instead of doing that inside the same file, just to make it look a bit cleaner, people have shifted it away to a different file. You can do the same thing with CSS as well. Basically, just shifting it off into a different file. I think with CSS, you use a meta tag use a style tag, I think, to import it. And instead for JavaScript, we import it with a script file, and we can set the script source here. And the script source will point to the location that the JavaScript file is at. Okay, phenomenal. Let's have a look at this JavaScript file, right? How do we write JavaScript? How do we actually perform stuff on behalf on the website? Like, the way we usually do it is, first of all, we need to find the elements that we want to actually modify, right? Or like listen to. And the way we usually do that is right here, is by finding its ID parameter. So we want to like find a button or something like that. I think I spelled button wrong there. Oops. Just correct that there. So we have something like this. We have button fetch, and we'll just get it by the ID. The ID is something that we include from the HTML. Like, see, you can see this button here. There's a button fetch. You can see the ID. And then we can just get it in JavaScript. This just allows us to actually get a look at it. And then, whenever we want to do something to it, we can just press this thing. For example, if we want to add HTML to it, we can do it like this. Or, if we want to add a function to it, we can listen to an event. We can do, what was it? Like, oh yeah, add event listener. We can do add event listener, yeah? And then we can just add whatever event we want to. You see, there's a lot of them. Basically, there's a lot of stuff we can listen to. If someone like hovers over the button, we can do something. We can like run a function. This could be good if you want to like, I don't know, make the button look nice or make some kind of animation play. You can do that with CSS obviously as well. But that's an option for you. One thing you might notice is that JavaScript doesn't have types. It's not a typed language by default. We have either constant, so const is something that you can't change. So once I define it, it's not changeable. Or you can have like a let. There's the two main ones. Like a let is something that we can change. It's like a variable. You can also have var, which is the one. I never use that though. I just use those two. Yeah, that's the main two things. That's how we define variables. They're not typed, so it's not like, you know, if you code like Java will have like ints and strings, stuff like that. JavaScript won't. That's why they're actually two very different languages. Don't get them confused. Java and JavaScript are two different languages. There is actually another language called TypeScript, which is kind of a Microsoft patch to this, because they wanted to actually add types into it. And the way TypeScript works is you like type like enter something here, like next to it. And instead of that, you'll have types in JavaScript. But by default, it doesn't have any types. So we need to declare variables. They're just like this. So that was a quick overview of some of the stuff you can do with JavaScript. Now, how do we hack JavaScript? What do we actually want to look for whenever we read it? Whenever we do any code review, we look for two things. We look for sources and we look for sinks. Sources are where user input will enter the code and start like flowing through it, right? And a sink is where that code will be executed and do something. In the case of client-side JavaScript, the main vulnerability type people look for is cross-site scripting. And that's a way to execute JavaScript code on the user's website based on some kind of user input that we control. The reason this is bad is because through JavaScript, we can do stuff like reach API endpoints with the user's cookies and credentials. That means that if we were able to do cross-site scripting on a website, we could have the user perform an actions they didn't intend to. You see here this fetch request, right? This fetch request can go up to like an API or something like that. And we're including the credentials. If the user clicks on the website and we have cross-site scripting, which means that we can execute JavaScript on behalf of the user, then we will be able to run that API endpoint and the user won't know. This could be like a delete account endpoint. So when the user basically gets affected by our cross-site scripting, we can like delete their account without them even knowing, which is obviously pretty serious. So websites want to prevent cross-site scripting. And there's a couple ways to do this, and the first way is to basically look at the sources and sinks and then make sure that user input is not being fed into a sink, which is not being executed. Let's look at the first sink that I've just created here, which is the sink with parameters. So this is a very common sink. It's where a parameter, so a search parameter, a query parameter, is taken from here, like this JS parameter, and is then fed into some kind of execution later down the line. In this case, I'm using the eval function. The eval function will take a string and evaluate it as JavaScript. That's obviously pretty good cross-site scripting potential there. And whenever we put this JavaScript parameter, we can do something like alert, and the alert will pop up. Cool. That seems like a cross-site scripting vulnerability. Nice. How do we exploit it? Well, what we would do is we would send a link to a victim, and we put our cross-site scripting payload here. For example, a thing that would, like a fetch request, that will automatically submit an API when the user clicks on it. Then when the user clicks on it, the parameter will be fed into the evaluation, and then the JavaScript will be executed. That's how this vulnerability will work whenever we attack it. This is called DOM cross-site scripting. So DOM is the stuff to here. And it's different from normal cross-site scripting because it actually runs on the client instead of on the server. Normally, cross-site scripting is where like the server will append like a tag onto the server when it's rendering it, the web page when it's rendering it. Then it'll be like cross-site script in there, right? Instead of that, this is actually executed in the JavaScript here, so it's not anything server related. It only runs inside the client. And that's actually very popular nowadays because most websites use client-side rendering now. Use stuff like React and Vue.js. It's rare that you'll see like a PHP website anymore with server-side rendering. So more DOM XSS type stuff is actually becoming more and more popular. But cross-site scripting isn't the only vulnerability we can find through JavaScript. There's a couple more of them. And for example, there's something like CSRF. So CSRF, cross-site request forgery, is a vulnerability I covered before. So if you don't know what it is, then please go watch that video. But in short, it's basically just a way to basically do the same thing as cross-site scripting. So run some kind of API endpoints on the user's behalf. It's a little bit different that we don't actually execute JavaScript to do it, but we kind of manipulate some endpoint to do it, right? Let's take a look at this code here, right? Read it, maybe take a second, see if you can spot where the vulnerability is. See how can we, let's say there's an API endpoint, another API input, like v1/delete, maybe like API/user, API/delete, like say this one, right? Say this endpoint will allow us to delete an account. So this is something that the user presses when they want to delete their account. How could we exploit it so that we can type in this ID and it'll instead go to this endpoint here? The way we can actually go and hit this other API endpoint by manipulating this prompt is by using a path traversal. Basically, a path traversal is where we put these kind of strings here, where we can put this kind of symbol here, and whenever we have like something like another path like VAPI1, it'll actually normalize the path and go back to the previous one. So path traversal is just a way of basically going backward paths. And there's another one like this, which just stays in the same one. It's kind of useless to us anyway. The most important one is this, which will go back a path. And then after that, we can put another endpoint like this. And once it normalizes the path, will be at a different endpoint. And this is normally attacked from the server, and it has been for a good couple of years. Let's say a server was fetching a file from some kind of directory, and what it was using like the name of the file, so it was like file name here. If you could control that file name, what we could do is you could go back the directory, so we could set the file name to something like //// and then we could go back to the root directory and read files from there. Usually we would read like etc/password. We can kind of do the same thing from the client side using client-side JavaScript. And this is called client-side path traversal. I made a video on it as well. It's a pretty cool one. Well, this is how it will look on the JavaScript code. Now, I can't actually exploit this vulnerability in my browser because I'm running this from a file, and this is protected by cores and stuff like that. And if it's not HTTP, it'll kind of break a little bit. But I can just show you here. If we go to fetch URL, I import //delete, like so, and I press OK. You can see it'll disallow reading the resource endpoint at the exact endpoint I wanted to. So if this was on a real website, then we could execute this client-side path traversal, and when the user clicks on it, then that would basically happen. It's unlikely that this would be like a prompt, even though this is not used, but this is actually not exploitable anyway because we'd have to get the user to type this in, which is unlikely. What it will usually be is like, for example, it'll take like window.location, and then it will get like the last one, right? So it'll say like path name, and then it'll get like the last path name basically using the string. What it will usually be is like when you have like an ID parameter, it'll have like 1, 2, 3, 4, 5. It'll take that and then put it into a different API endpoint. So just the last parameter. And what we can do is we can put the .. here just in a URL encoded way instead. So like this, and then this will be decoded hopefully by the server here. It'll be placed into the string, and then it'll make the path traversal. That's how we can exploit something like client-side path traversal, and we can get a CSR type vulnerability. So something else to look out for whenever you're actually reading your JavaScript. And this is just another kind of sink. The sink in this case is the template literal. Next thing that I want to talk about is post message. And this is another sink that I think is very underrated by most people. A post message is kind of confusing, but it's a way for a website, so the main website, to talk to an iframe which is inside of the actual website. Remember in my HTML video, I talked about iframes. Here you go. And it's actually a way to include or embed another website inside an already existing website. Instead of opening a new tab with the website, we can just embed it inside our own website. In this case, the iframe is here. Why would we want to do this? It's good for stuff like widgets, for example, like notification pop-ups or something like that. Because instead of loading it onto our own website, we can just create it once and then load it like a load of times from different websites. And that just saves us a lot of development work, first of all. And it's also quite efficient. That's why we might want to use iframes in order to embed stuff into our own website. But these iframes, they can't just talk to each other like normally. Why can't an iframe just like basically be part of the website? Well, if you clicked on a malicious website and they say embedded your bank account onto their website, which they can do with an iframe, since they've done that, the website will load with your cookies and stuff like that. If they could just access the website, they could read like your personal details off, right? So we need to prevent that from happening. We need to prevent the attacker website being able to like read your personal details from an embedded website. That's where the same origin policy comes in, which also applies to iframes. So you can't read data from inside an iframe unless you're in the same origin, which means the same, like, what's it called, like host name here, basically. Unless you meet that requirement, you can't read stuff from, and you can't like send like requests or anything like that. You can never read cookies basically as well. That's basically the requirements that are set by the same order policy, and it's to protect your details from being stolen by attackers, and it's a very good thing. What if you need to do it though? Let's say you have a widget, you've loaded it in, and you need to send data to it, which is quite normal. Like say you had a widget on the side of the website, and it said like welcome, and it's like your username. Well, the widget has to know your username, but the username is only known by the website, right? So we need a way to pass your username into the widget, for example. And the way we do that is using something called post message. It's kind of like HTTP Lite, just for iframes. It's very funny. You can send a message to the iframe, and the iframe can choose to receive it, and then process it, and then it can send a response back to us. Let's see here. When the user clicks a button, it's like here. This is an alternative way to write the thing here about the event listener, just like this. So when the user clicks a button, we're going to get an iframe with ID child. Let's go back here. So here's the iframe, and it's just loading in widget.html. It's going to get that, and then it's going to send a message. And it's going to send a little bit of HTML to it, right? And then, later on, it's going to wait for an event from a message, and then it's just going to log it into the console. So this here is how we can listen to post messages, and this here is how we send post messages. Let's go to widget. And here I've just written it into the script just to be a little bit safer. And we have the same thing. It's listening to a post message. It's putting the notes inside inner HTML, and then it's sending a response back to us. So this is the kind of two-way communication, right? Instead of like actually doing this from the top website, which we can't do, we've sent the information down to the widget, which is then going to process it, and then it's going to do stuff with it. That's phenomenal. There's a bit of an issue here though, and there's a few security concerns that come with post messages. See, anyone could open an iframe, right? So I can iframe this widget myself if I wanted to. And if the widget contains some kind of sensitive data already, and I send a post message to it, if it just eats up the sensitive information without checking if the origin above it is actually authorized to see it, it could leak your user data. And they've done a few patches to actually prevent this from happening. I didn't really explain this little star thing. The star thing is actually a way to specify what origin we will allow this post message to go to. Because all of these post message things were happening, vulnerabilities were happening because people weren't checking the origin. So they added this in, and this star means that any origin is allowed. And it's generally frowned upon to use this inside production unless it's absolutely necessary to use it. Sometimes you have to use it if you have like multiple origins using it. But what we can do is we can specify different like domains inside here, and this will prevent some kind of vulnerabilities. The other way we can do it is by checking the actual source of the event here. So we can check this manually by doing like .origin, and we can check it, and we can use .source. Source I think is a bit more secure than origin. Origin can be kind of manipulated a little bit by using sandbox iframes. So source is generally more reliable. Another thing is that if we can pass data into the post message, and it handles it insecurely by trusting the source that's sending it, well, then we can actually find the sink inside the post message and then execute cross-site scripting there as well. So you see this inner HTML page. This inner HTML is another sink, and this will just inject a string straight into the HTML, and it will parse it as if it's HTML. So if you put like a script inside of it, it will parse it as a script, and then the rest of it will parse as JavaScript, allowing us to get a cross-site scripting vulnerability. And this is one of the bigger sinks actually. It's inner HTML, and I think it's quite insecure to use this anyway. So you want to make sure that the data that's being passed into this is safe. It's definitely going to be trusted. Sometimes you really need to use this for a variety of reasons. So that's what will allow us to send a post message. And the same thing applies obviously on the top level domain. It's also able to receive post messages. Remember that I can also iframe this domain, so it's not just like a top level domain. I can iframe this and then send a post message to this. So this is doing, if it's handling this insecurity, trusting its iframe, like this child iframe. I can iframe this as well if I want to, and then send post messages to it. So you really have to be careful about when you're actually receiving these messages. So in this case, we'll just test out what this is going to do. I'm going to click this post message button. You can see this was sent with post message, which is what I sent, and then you can see the actual HTML here, which is reflected on the page. I have this tool called post message tracker, which shows me whenever post messages are sent, and this is the data that gets sent from the top level iframe, and then the bottom level iframe sent data as well. What's cool about this tool as well is that it allows you to see where the post messages are actually being tracked. So you can see this function here is the one inside the iframe, and this one is just this thing here, right? So it just allows me to see it at a glance, and it allows me to see it without basically just looking through all the JavaScript, which is nice. So how can we exploit this? This is insecure because it's passing HTML directly. It's not checking the origin. So this widget here isn't verifying the origin, and it's just directly yeeting it into inner HTML. There's obviously no sensitive data here on this widget, but if there was, then we could execute some kind of cross-site scripting. So how would we execute this? Well, the simplest way is just to make our own little HTML page. Like here, we'll just create our own little exploit. We'll say HTML, just define a few things, body, and then we want to make a script diagram. So what we want to do is we want to iframe the widget. Going here, we want to declare an iframe like this, iframe, with the source being widget.html, like that. Then we want to set an ID, say child, like this, and then in the script we want to find the widget. So document.getElement by ID, finding child, and then sending the post message to it. We can just go back here. We can go back to the main script here. We can go, say, just copy paste this stuff. Child.context window. We'll just copy paste it directly from the main one, and then it will say here that a child will say frame.content window the post message. And instead of that, we're going to send a malicious post message this time, which is going to allow us to get the vulnerability. I'm going to say like script alert, like this thing here. We get this down here as well, and then we'll say like that, any origins allowed. Yeah, and hopefully this will work. I might have to add a few things to it, and then we'll go into evil.html here, and then what's happening here? Sometimes you might need to actually wait for the iframe to open before you actually send the request. So we'll just go here, say unload like this, and then when it's loaded, you can just post the message. So we'll just say here, then hopefully the iframe will do that stuff. Maybe not. Okay, it's injected the script alert. I don't know why it hasn't popped though. It should have popped. Weird. Maybe we'll try a different payload. We'll say image source x on error, which is equal to alert, like this. I'm just close this here. We'll save that instead, and then you can see the alert is popped. So it's popped inside this iframe. So that this is not like an XSS cross-site scripting vulnerability on this website. It's actually affecting the inside the widget. So we can use the cookies from the widget and not on the main website. That's how this cross-site scripting vulnerability works there. And yeah, that's kind of it for post messages. We can send a request in, and then we can either get a sync, or we can hope that the post message will throw up some kind of sensitive information if it hasn't. Those are the two things that we can kind of hope for when we attack post messages. And just to end off the video, I'm going to talk about some JavaScript libraries that I often see. JavaScript libraries are things that other developers import into their code and that they run on the client side. And DOM Purify is one of the ones from a security perspective that is actually interesting to us. Just go back to the main one here. Well, DOM Purify, what it does, it allows us to write HTML onto the DOM, but it filters out cross-site scripting. So it prevents us from doing stuff like adding in like script tags. It prevents the attributes that allow JavaScript inside of them, and it will prevent those cross-site scripting vulnerabilities. Well, why might someone allow people to write JavaScript, or why would they allow this? Well, say you have like a profile, and you have like a profile inside a web page, and we want to allow users to add a description. It makes sense to allow them to use Markdown on the web page to actually like underline text or like have like a text editor and stuff like that, just to look a bit nicer here. And to do that, we have to sanitize away all the possible cross-site scripting stuff so that it doesn't end up affecting the actual web page. And to do that, a lot of people use this library called DOM Purify, which you can find here on the internet. Usually the way you include it is you just download it and then you just add a script tag. As you can see, I've added right here, it's called purify.js. And that will allow us to actually use it inside our code. You see here, we can use DOM Purify, this class name here, and then we can sanitize stuff away. Let's try it out. We'll write something like test here, like that, say okay, and you can see that we've actually injected the HTML. So that's nice, that's intended, we want to do that. Now what it's not intended is, for example, if I came here and wrote like script, instead of that, and then I said like test next to it instead, so yes, we put it down, and you can see that the script did not make it into the actual DOM, so it was sanitized away. That's the main way people use DOM Purify. It's just sanitize away all the cross-site scripting. It's very safe. It's like gets regular updates. If people are using the latest version of DOM Purify, there should be absolutely no issue. There are like regular security problems that emerge. Like for example here, September 16th, October 11th through 31st, 2024. Vulnerabilities do happen in this library, as they do in like every library, so you need to keep them up to date. The main way you can find a vulnerability with someone using DOM Purify is to see what version they're using. If you go here, they're using version 2.4.2, which before that was affected by this prototype pollution vulnerability. It was critical. So I imagine you could just do like a cross-site scripting vulnerability there. You can see the latest one is 3.3.1, which it will say it on type the DOM Purify script. So if you see this Purify and you see this version is like lower than this, that means that you can go read up on this commit message here. You can load this diff here and you can figure out what was wrong, and then you can launch the vulnerability from there. That's the main way that you can exploit JavaScript libraries, is by looking at the previous security vulnerabilities and then seeing if they're using an outdated version. I hope you enjoyed this video on reading JavaScript. I think it's one of those underestimated skills that a lot of bug bounty hunters don't look for. These kind of client-side vulnerabilities. Well, a decent bit of bug bounty hunters do look for it, but I think there could be a lot more space to actually look for client-side vulnerabilities. There's a lot of pressure on looking at the server, but the client will also have a lot of vulnerabilities, sometimes that are even more severe than the server. So keep that in mind when you're attacking your new bug bounty program. If you use some of the stuff, look for post messages, look for template literals, look for these fetch endpoints that have the thing. If there's template literals in there, look for client-side patch reversal, and obviously look for your sources and sinks, which are the most important thing. Look for places where user input is put into the JavaScript, and then where it eventually ends up being turned into some kind of, to be executed as JavaScript or placed into the HTML. And yeah, if you enjoyed this video, then please like and subscribe so you get more content like this recommended to you in the future by the algorithm. If you have any video suggestions, then leave them in the comments below. This video was actually made from a suggestion by another viewer just like you. So if you're still watching, it's probably like 3 people that have made it this far, because just attention spans are absolutely fucked. So good on you, having good attention span. You really need it to be a good bug hunter, so well done on making it this far in the video. And yeah, that's it for me. Thanks for watching, and happy hunting.